In today's video, I'm going to show you how to procedurally generate a hexagonal grid pattern like this. Let's go. Alright, so right at the end of last week's video, I showed you how we could use a hexagonal grid pattern like this to break up texture tiling. Normally, when we have a large object that we want to add textures to, there are a lot of tiling artifacts, and we end up with a pattern that looks something like this, so here I've got a cobblestones texture, and I'm just tiling it over and over and over, and you can see that repetitive pattern, and it really causes an issue that makes our scene look less realistic because we can see the repeating pattern. And in nature, there aren't usually patterns like this that repeat over and over. And so we need a method to be able to break up this kind of pattern. Well, I have a method here that uses this hex grid that we were looking at to randomly offset, scale, and rotate each of the hex grid tiles. And we end up with a result like this, where each of those tiles is randomly offset and rotated, and then blended with all of the other ones. So we have smooth transition between tiles, and each tile has a slightly different random transform applied to it. And so a pattern like this can tile forever without seeing any repetitive tiling artifacts. So today we're going to begin the process of learning how to set up this effect. Now it is a little bit complicated, and so it's going to take a couple of videos for me to split things up and explain how it works. Today we're mostly going to be focused on generating this red, green, and blue tiling pattern. And then in next week's video, I'm going to show you how to use this tiling pattern together with the UV random transform nodes that we created previously to apply random transforms to each of these individual tiles so that we can break up our repetitive tiling pattern and create some textures that can be repeated over and over and over without any tiling artifacts. All right, with that explanation out of the way, let's jump right in. Today we're going to be starting out in Unity, and once we build this effect up in Unity, I'm going to show you how to build it in Unreal as well. So the first thing that I'm going to do is I'm going to create a brand new subgraph. So I'll just go to Create, Shader Graph, Subgraph, and we're going to call this subgraph Hex Grid Demo. And I'll just double click it, and we'll jump right in. Our Hex Grid Demo subgraph, we're going to be constructing this in 4 steps. The first step that we're going to do is to create, very first, we need to just lay down some UVs. So I'm going to bring in my UV coordinate node here. And just so that we can get some tiling, I'm going to multiply the UV coordinate by 6 so that we have 6 individual tiles here. And because this is a vector 4, I'm just going to isolate it by applying a swizzle node. And for the swizzle, I'm just going to use the X and the Y. We only need the U and the V coordinates of our UVs, and so I'm just going to isolate the X and the Y here. Okay, so now that we have our UV coordinates and we're tiling them 6 times, let's go ahead and begin the first step of the process, which is generating a red, green, and blue grid. So to do that, the first node that I need here is a floor. So I'm just going to go ahead and round down my UV coordinates to the nearest whole number. So 0 becomes 0, and then any values between 0 and 1 become 0. So this is just going to round down to the nearest whole number. Then I'm going to split my values apart into their individual U and V coordinate. And then I'm going to subtract V from U. So I'm going to add a subtract node here and subtract one from the other. And that's just going to split up my graph like this, where these values are lower and these values are higher. And then I'm going to differentiate the values a little bit so that each square has either a 0, a 1, or a 2 by adding a vec3 value here. And so each of my values are going to be 0, 1, and 2. So I'll just add these values to my grid squares here. All right, the next thing that we need to do is multiply by 1/3. And I found that this particular math operation is really sensitive to getting the decimal value just right. And so what we're going to do here is I'm going to add a float value of 3, and we're going to take the reciprocal of this. So I'm just going to add a reciprocal node, and this will give me a perfect value of 1/3 that I can then plug into my multiply. Okay, and then the next thing that we need to do is add a value of 1.6666, or 5 divided by 3. And so again, I'm just going to take a float value here and give it a value of 5, and then I'm going to use a divide, and we're going to divide this by 3. Now, these hard-coded values that are doing math, this math will not be done every pixel, every frame. When the shader is compiled, this math will be done beforehand just once, and then the value will be stored. But because I'm specifying these, there's this really interesting thing that happens with decimal values that repeat, like 3333 or 66666. If you go ahead and do the divides like this, you'll get the most accurate number that a floating point value can create. Whereas if you type it in yourself, sometimes it's not accurate enough. So this is going to be 5 divided by 3, and I'm just going to throw that into my add. And then to finish off my grid here, I'm going to add another fraction node to take just the remainder or the decimal portion, and then we're going to round this to the nearest whole number, either up or down. And there you go. We've created a blue, green, red repeating grid. And so this is a procedural method of creating this grid. And so this is the first step to creating our hexagonal grid. Now I'm just going to go ahead and clean up our graph a little bit, maybe consolidate things, and then we're going to start on the next step, which is to create a hexagonal mask. All right, there we go. If you've been watching my videos for a while, you know I like grids that are nice and compact like this. So once I get done creating something, I'll just go ahead and compact it. All right, let's take our UV coordinates again, and we're going to drag a line down here, which is where we're going to work on step 2, creating our hex mask. So let's create a fraction node first. And then we're going to split our fraction into the red and green channels. So there's our red and green. And then we're going to, instead of subtracting them like we did up here, we're going to add them together this time. And we'll end up with something that looks like this. And then we're going to subtract 1. So I'm going to add another subtract node. And we're going to subtract a value of 1. And so we're kind of creating these little triangle gradients here. All right, then I'm going to take the absolute value of this. And then I'm going to come back here to my fraction node and come down. And I'm going to swizzle these. So I'm going to reverse the order. So here's our swizzle node. And in here, instead of x, y, I'm going to type y, x. So I'm swapping these channels around to the opposite side, and then I'm going to invert it with a 1 minus node. So I'm kind of creating the opposite of what I have up here. And so I either need to take this version or this version, and so what I'm going to do is create a comparison node. So here from my subtract, I'm going to drag out and create a comparison. And what I want to do is find out if this value is greater than 0. And if it is greater than 0, I'm going to go ahead and add a branch node here. So if it's greater than 0, we're going to use this side of the branch. And if it's less than 0, we're just going to go with the value that we're getting from our fraction up here. So I'm going to grab this and drag it down and wire it in there. All right, I hope you're with me so far. We're just about done with this step. So now from our absolute value up here, I'm going to drag out and create a combine. And we're going to wire this combine into the red, or we're going to wire the absolute value here into the red. And then we're going to take what we've created here with our branch, and we're going to split it up, and we're going to take the red channel and put it into green, and we're going to take the green channel and put it into blue. So we end up with a little bit of a grid pattern that looks like this. Now, in order to turn this into a hex grid, we need a little bit of help from this checkerboard up here. So I'm going to drag out 3 swizzle nodes from this checkerboard. The first one is going to be ZYX. The second one is going to be YZX. And then the third one is going to just be XYZ, the standard one. So what I've done here is taken this and scrambled it so that on this one, the red square is first, on this one, the green square is first, and then on this one, the blue square is first. And so now what I can do with these is I can take the dot product between each of these and each of the channels here. So I'm going to drag out here and add a dot product node. And this we're going to do a dot product with the RGB here. And then this we're going to do with this dot product of this one. And then finally we're going to do a dot product with that one. And it looks like I may have made a mistake here. You can see how I've got these nice hex grids going on with this. But on this one, we actually need it to be ZXY. There we go. So now we have 3 different hex grid patterns. And we can take these 3 and combine them together into a single hex grid. So this will be the red, this will be the green, and this will be the blue. Okay, we're almost there. You might be saying now, I can sort of see a hex grid there, but it's kind of blurry. And so now we're moving on to step 3. So this is step 1, creating our red, green, and blue checkerboard grid. And this is step 2, which is creating our hex grid pattern here. Actually, you know what? Before we go on to step 3, I'm just going to clean up my grid again. So let's just go ahead and consolidate things. So there we go. There's our result of step 2, creating our hex mask. And then finally for step 3, we're going to sharpen our mask up because this is pretty blurry looking. So I'm going to just drag out and add a power node. And this exponent that goes into power will control how sharp our mask is. So we can take this and divide it by the dot product of 1, 1, 1. So if I just add a dot product here and set these values to 1, 1, 1, and then we divide our original value by that, now we end up with a sharper mask. And you might be saying, well, that's still pretty blurry. And if we just come over here and increase our power, The higher this power value goes, the sharper our mask is going to be, and the smaller the edges between each of the grid squares. So I can expose this on my blackboard here. I'll open up my blackboard, and let's just add a value here called, maybe we'll call it hex focus. And we can wire hex focus into our power B slot here. And then maybe we'll give it a default value. If I come over here to my graph inspector and select hex focus, now I can give hex focus a default value. I'll give it a default value of 6 so that my grid squares are not too sharp and not too blurry. Okay, cool. We've got a hex grid. But you might be saying this hex grid doesn't really look hexagonal. It's kind of squished and it's kind of diagonally, right? That is what we need to fix in step number 4. So before we go on to step 4, I'm just going to clean up my grid again, kind of consolidate these nodes and pack things in a little bit. And there's our result of step 4. So in order to get this looking more like a standard hexagonal grid, we need to come over here and manipulate our UVs a little bit. So here's where we're going to work on step 4. All right, so in order to manipulate our UVs, first thing we need to do is split them up into U and V. And we also need to add a float value down here. So I'm going to add a float, and this is going to be 1.732. So we're going to take 1.732 and divide it by 2. And then we're going to take the reciprocal of that, or this value over 1. And we're also going to take this value and do another divide. But this time we're going to divide 0.5 by the value. And then we're going to take this value and add a multiply. And we're just kind of building things up here slowly. So we're going to take this reciprocal and multiply it by the green channel of our UVs. So we're going to multiply this by V. And then we're also going to take V here and we're going to multiply it by the result of this divide. All right, and then we're going to take our U coordinate here and we're going to subtract the result of this multiply from it. And that's going to give us a nice diagonal angle. So now what we can do is combine this value here. We're going to put this value in the red channel. And then we're going to take the result of this multiply and put it in the green channel. So now we have some adjusted UVs that we can use for our hexagonal grid. But there is one more thing that we need to do. We need to take the result of our combine here and we need to divide it by 2. So now we've divided that by 2. And so here is the grid that we just created for adjusting our UVs so they'll work correctly with a hexagonal grid. So now if I take these adjusted UVs and plug them into our step 1 here, you can see that it's tilted the grid into diagonal. And now if I plug them into step 2 here, now we come over here and we look at the output of our grid, and now we're getting a great looking hexagonal grid. Cool, we did it. We made it all the way through this process. I know it's kind of complicated. I hope you were able to follow along okay and that you got all these values correctly. Let me know down in the comments if you run into trouble or if you have questions about how this works. Let's go ahead and increase our multiply here just to see if we can make a little bit bigger grid. Yeah, there we go. So we've got our nice hexagonal tiling grid. And now all we need to do is take this and apply it to our texture tiling. But this video is getting a little bit long, and we still need to cover the process in Unreal. And so I think what we're going to do is cut it here and jump over to Unreal. And then next week, we'll pick up here, and I'll show you how to use this grid together with our random UV transform node to create or to break up our texture tiling. So let's take one last look at what we've done here. In step 1, we created the red, green, and blue grid. In step 2, we converted that grid into a hex grid. And then in step 3, we sharpened it up so that the edges are a little bit sharper. And then finally, in step 4 over here, we fixed up our UVs so that they work well, and we can create a more regular hexagonal pattern. So we have our whole thing, and we have our final red, green, and blue hexagonal grid. And the benefit of this is we can do a couple of different texture samples and then blend between them based on red, green, and blue. All right, cool. Let's switch over to Unreal, and I'll show you how to do the same thing there. All right, here we are in Unreal, and we're ready to go ahead and make our hex grid material function. So I'm going to right-click here and go to Materials, Material Function. And then I'm going to call this MF Hex Grid Demo, just like we did in Unity. And then I'll open up my new material function, and I'm going to switch this over to be a square, just so it'll be a little bit nicer to look at. I'm going to set the field of view to 50. All right, so we're ready to start creating our hex grid. And just like we did in Unity, I'm going to do this in 4 different steps. Before we get started, we need to bring in our texture coordinates, and I'm just going to multiply our texture coordinates by 12 just to give us a decent sized grid to work with. And now we're ready for step 1. So in step 1, we're going to create our red, green, and blue checkerboard grid. So in order to do that, first thing I need is a floor node. And then I'm going to split my U and V coordinates using a component mask. So I'm going to use the red channel for the first one and the green channel for the second one. And now that I've got them split, I'm going to subtract the V from the U. So I'll add a subtract node here, plug the red into A and the green into B. And now the next thing that I need to do is go ahead and actually we can just kind of preview these as we go along. So I'm going to click on start previewing node just so you can see what's going on at each step. Okay, now we need to differentiate our squares. So I'm going to add a vector 3, hold down the 3 key and click. And I need a value of 0, 1, and 2. So for every square, I'm going to be adding 0 to the red channel, 1 to the green channel, and 2 to the blue channel. And this is just going to help differentiate the squares and split them up a little bit. Just going to preview that. Now the next thing that I need to do is multiply by 1 divided by 3. So we're going to add a multiply node here. And then I'll do 1 divided by 3. And then we'll plug this into our multiply here. There we go. And I'll preview this node. So what we're trying to do here is get 3 different grid squares. So now that we've multiplied by 1 divided by 3, the next thing that we need to do, and I'm just going to kind of clean things up here, keep us going in a straight line. The next thing that we need to do is add 1.66667. So we'll put in an add node, and then we'll change this value to 1.6666667. Great, and we'll add that. And now we need to take the fractional portion of the result. So I'm going to add a frac node. And we can preview this. So we're almost there. The last thing that we need to do is round. So this is going to take each of the channels and either round it up to 1 or round it down to 0. And this will give us our final red, green, and blue checkerboard grid. Pretty cool. So that's step 1 of the process. Now I'm just going to kind of compact these nodes together a little bit so that we have a nice tight graph. The reason I like to have compact nodes, some people don't, some people like to spread their nodes out a little bit, but I like to be able to see as many nodes as possible in one view. And that's why I kind of pack them close together like this so that I don't have to zoom way out to see what all my nodes are doing. All right, so for step 2, the next thing that I need to do is create the hex grid portion of my grid. So I went ahead and I created kind of a checkerboard grid here now. Now I need to turn it into a hex grid. And so the way that I'm going to do that is I'm going to take my coordinates here. We're just going to come down here to give ourselves a little bit of space. And I'm going to drag out from my coordinates and create a frac node. So I'll just preview this. We'll just go ahead and preview as we go along so that you can see what's happening. So you can see that now, because I've multiplied by 12 here and used a frac, I've split my grid into like individual little UV squares. All right, the next thing that I need to do is split this out into the individual channels. So I'm going to use a component mask for red and another component mask for green. And then I'm going to add these together and we'll preview that. And then I need to subtract 1. So just add a subtract node, give it a hardcode value of 1. Then I'm going to take the absolute value of this. I'll just add an abs node and take a look at that. Okay, so now this is going to be the first part of my vector. So I'm going to add an append node here so that I can make this the first part of my vector. And now I need to work on the second part, and that's going to go down here. So I'm going to add a swizzle node. And we're going to make XYZ into, or I'm sorry, we're going to make XY into just YX. So we're going to invert it, and then we're going to add a 1 minus node here. So we're going to flip it around. So we swapped channels, and we inverted the result of that. Now we need to add an if node, a conditional. So I'm going to add an if node here. So our A value is going to be the result of our subtracting 1 here. And our B value is going to be 0. And so we're going to say if A is greater than B, then we're going to use this value down here. But otherwise, we're going to use the result of our frac over here. All right, and if we preview this, we get a little something that looks like that. And then we can plug this into our append. This is going to give us our green and blue channels. So if we look at what we've created here by appending this vector, we get this kind of funky looking grid. Cool, so we're about 2/3 of the way there with step 2. The next thing that we need to do is introduce our values from our red, green, and blue grid from up here. So I'm going to take what I'm getting from my round value here and add a split components node because I'm going to be using all 3 of the components here, red, green, and blue. And just like we did in Unity, I'm going to take this grid that we created and create 3 different versions of it. The first version, I'm going to swizzle it. So in order to swizzle this, I need to use an append many node. And so we're going to take the blue channel and plug it into red. We're going to take the red channel and plug it into green. And then the green channel and plug it into blue. So you can see I just kind of swizzled it all around there. For the next one, I'm going to take the green channel and plug it into red. I'm going to take the blue channel and plug it into green. And I'm going to take the red channel and plug it into blue. And now, from these append nodes, I'm going to do a dot product here with the result that I came up with down here. And then I'm going to do a dot product again with the second one with the results that I came up with down here. Notice now, with each of these dot products, I'm taking the RGB of the append many. And then my final dot product is just going to be with my original value here. So instead of mixing this one up, I'm just taking it as it is. I'm going to take this value and do a dot product there. Then I'm going to take one more append many node, and we're going to bring all these values together. So this will be my red value, my green value, and my blue value. Now we can preview this node and take a look at what we're getting. And you can see that just like we did in Unity, we're getting this hex grid pattern. It's kind of a honeycomb shape. And this is the hex grid pattern that we're looking for, but just like in Unity, it's kind of tilted over. We'll get to that in a minute. That's step 4. But the next thing that we need to do is step 3, where we sharpen it up. And so the way that I'm going to do that is just pull out here and add a power node. And the value that I plug into my exponent pin here is going to be how sharp things are. And so for now, I'm just going to add a hard-coded value and give it a value of 6. I'm going to wire this in. And now I need to divide the result of that by the dot product of it. So I'm going to add a divide node here, and then come out of power again, add a dot product, and we're just going to dot product it with a value of 1. And then we'll plug that into the B port of our divide. So if we preview this now, you'll see that we've got a grid that's significantly sharper. It's still tilted over on its side, mind you, but now we have this value here that we can use to control the blurriness or the sharpness of it. So if I turn it down to 2, you can see it'll get nice and blurry. Lots of like really broad blend zones there. But if I turn it up to 12, now it'll get significantly more focused, and our blend zones are quite a bit smaller. All right, so that is step 3 to sharpen things up. Just to review here, we've got step 1 is our red, green, and blue grid. Step 2 is this part and this part over here, creating our hexagon. And then step 3 is to sharpen things up a bit. And now we need to do step 4, which is kind of turning our tiles so they're not going diagonally. And in order to do that, we need to come over here and modify our UV coordinates. So we're going to take our UV coordinates, and again, we're going to split them into components. So we have our red and our green. And then we're going to take our red here and add a subtract. And we're going to create this subtract value here from our green channel. So let's take our green channel and we're going to add a multiply. And we're going to add another multiply down here. And bring this guy out like this. Now we're going to add the magic number for hexagons, which is 1.732. And this is what creates our angle. So right now it looks like it's leaning over on its side, but this 1.732 is the magic angle that hexagons use. So we're going to divide that by 2. Then we're going to add another divide here. And I'm going to plug this into the B socket of that divide. And the A socket is going to be 0.5. And then we're going to plug the value of this divide into the B socket of our first multiply here. And we're going to take this divide down here. And we're going to get the reciprocal of it. So I need, Unreal doesn't have a reciprocal node, and so I'm just going to put in another divide, and plug this into B. And then we're going to add a value of 1 and plug that into A. So 1 over the value of this divide is going to give us this. And we'll plug that into our second multiply. Okay, so our first multiply is going to go into this subtract here. Then we're going to add an append node and put our UV coordinates back together. So what we're getting here is going to be our U coordinate, and what we're getting here is going to be our V coordinate. And then the last thing that we need to do is divide it by a value that represents the size of our hex grid. We're not exposing values right now. We're going to get to that next week when we create a proper material function. We're going to expose a bunch of values that allow us to control the tiling of the grid and how big each of the tiles is and that sort of thing. For now, we're just going to add a constant value. This is going to control our hex size, and I'm just going to give it a value of 1. So let's plug that into our divide here. And this is step 4, what we needed to do to adjust our UV coordinates. So then now that our UVs are all nicely adjusted to create a proper hex grid, we can plug those UVs into our hex portion. Now it looks crazy, but we can also plug it into our grid portion up here, and bingo, we've got our hexagonal grid. So we've got step 1, creating the red, green, and blue grid, which gives us this. Well, now that I've adjusted my UV coordinates, it's going to give us a tilted grid. That's what we need for the hexagons. So we've got our grid here, and then we created a hexagon grid here, but it's too blurry, so we sharpen it up here, and now we're done. So our nice clean 4 steps. Step 1, step 2, step 3, and then step 4 was fixing our UVs to tilt the grid the right way. Okay, pretty cool. So we've got a material function now that creates our red, green, and blue hexagon grid. And next week, like I said before, we're going to go over the process of taking this grid and using it together with our random transform node to create nice tileable material that actually doesn't show any of the tiling artifacts. So be sure to come back next week for that. In the meantime, have a great week, everybody. We'll see you next time.